Evening, folks. Brian here, Geomagnetic Earthwatch, Saturday, August 17, 2024. We're going to talk more about data analysis, correlation, and causation of low-pressure systems resulting in increased muon counts, which equals seismic and volcanic responses. So there is a correlation between pressure deviations and relative cosmic ray variations. There's many scientific papers out there. You can read up on it. Now, cosmic rays interact with the top layers of our atmosphere about 15 to 20 kilometers up. And when they interact with the atmospheric nuclei of the air molecules, this produces larger amounts of secondary showering particles we call muons, which propagate towards the Earth, traveling at almost the speed of light, and they do penetrate through almost all materials, including the crust of the Earth. And because they rain down on us, so if you have one single primary cosmic ray interacts with the atmospheric nuclei, it creates secondary showering particles, which can come down on us at all angles, straight down, at an angle, horizontally. Secondary showering particles. It also contains not just muons, mostly muons, but also electrons, pions, and neutrinos. So as I discussed before, when muons penetrate the crust and interact with silica-rich magma, a process called bubble nucleation takes place. It heats up, it rises up, it pressurizes. Once again, it doesn't have to happen at the outer core. Even though the charged particles reach that far from the magnetic cusps, up through the mantle plume to the mantle plume head. Right around here is the mantle transition zone, where deep earthquakes commonly occur between 410 and 660 kilometers deep. So the magma and the pressure that has to carry it exerts the pressure underneath the crust, resulting in earthquakes and or volcanic eruptions. So again, there's lots of scientific papers on the relationship between atmospheric conditions and muon flux. The atmospheric conditions is 1, atmospheric pressure, and 2, atmospheric temperatures. And so what I've done is I've taken these studies and I'm working myself on developing a forecast model, such as I've demonstrated half a dozen times already. I will show you the track of a low pressure systems. I will suggest there will be an earthquake, and 24 hours later there was an earthquake. Last year there was a cyclone track south of Japan over the Isuzu Island regions. Immediately following, many magnitude 6+ earthquakes over the Bonin Islands, Isuzu region. The hurricane that tracked through the Caribbean, directly in line of the track, Martinique earthquake in the middle of the Caribbean plate earthquake. Very recently, I showed you the track of the low pressure, the cyclone past Tokyo, 2 magnitude 5+ earthquakes. And that 7.4 earthquake off of Kamchatka was 24 hours after another low pressure system passed right through. I'm sorry, I do not believe that the recent G3 geomagnetic storm triggered that one. That's just my own belief, because that earthquake happened 1 hour and 34 minutes after CMB impact. the soonest you can expect any response is 12 to 24 hours and up to 72 hours after coronal mass ejection, solar storm impact. So again, I've shown you my theory, and I've proved it, and that's what I'm going to be working on. I'm going to try every day from now on, actually, to show you the track of all these low pressure systems. So the way it goes, folks, is when you have a decrease in atmospheric pressure between 990 and 1,000 hectopascals, this results in increased muon penetration. On the opposite end, on high pressure systems, this represents a thicker absorber, resulting in fewer muons reaching us. Low pressure system, more muons. High pressure system, less muons. Also, atmospheric temperature changes is also an additional cause for seasonal variation of cosmic rays intensities, temperatures. It's called the temperature effect. There is a decrease of muon intensity at ground level during heating and the expansion of the atmosphere above. Increased temperatures result in lower density properties, which decreases the possibility of atmospheric interactions of the primary cosmic rays, resulting in the secondary showering properties. Atmospheric pressure, low pressure, and dropping temperatures result in increased muon penetration. Now, because of the ongoing geomagnetic excursion, which is destabilizing and weakening our protective magnetic field, it is also destabilizing and weakening our jet streams, which creates our weather patterns and pressure systems. So we need to track these low pressure systems as they pass over subduction zone, other fault lines, volcanoes, and areas of thinner crust, oceanic crust. That low pressure system that just passed by Kamchatka is on its way to the tip of the Aleutian Islands and then into the Bering Strait. The cyclone that's already passed Tokyo is now heading towards the Kamchatka Peninsula. It'll be there Monday. Oh, and by the way, earthquake swarm, southwestern Australia, close to Perth. Yeah, you got it. Low pressure system. Just tracked through there the day before. Take a look at your earthquake maps for Iceland. Increased seismic activity in the middle of Iceland and northern Iceland. What happened? Low pressure system hung over Iceland for a while. So we need to be extra vigilant during geomagnetic storms and low pressure system activity. Geomagnetic storms, especially the bow shock, the day side, the compression into our magnetic field, into low pressure systems. Maybe indirectly. No. The timing of the CME impact was Mexico, Nicaragua. The radio blackout was the Pacific Ocean between Central America and Hawaii, not Kamchatka. So I just want to do an update on the effects of low pressure systems on our planet. The 1991 Pinatubo eruption in the Philippines was right in the middle of a cyclone. Another example. That's all for now. It's late.